Hello, Algebra 2. Here we are with the first lesson of a new unit, reducing radicals and rationalizing. Okay, so there's two main ways to reduce radicals that you may have practiced before. A lot of us are going to practice either the factor tree method or the perfect squares method. Okay, the factor tree method is you break them apart into factor trees as far as they'll go, until you have a bunch of unfactorable numbers. So 32, we can go 4 and 8, you can do 2 and 16, whatever. You're going to keep breaking them up until we get down to something like this. A bunch of 2s for 32, so it's going to be a lot of prime numbers, like 2, 3, 5. Okay, keep going all the way down. And because we're doing a square root, which undoes squares, you're looking for partners. So for every partner pair, and they don't have to be next to each other like this. I could have used like these two and those two. Just as long as you have 2 of a number on the bottom of your tree, you get to partner them up. And for each partner, that is a big number on the outside. So for that partner, here's 1, 2. And for this partner, here's 1, 2. Because you're doing a square root. So this is like 2 times 2, 2 squared. So you're doing the square root, so you're only going to write it down once. And then for every leftover single number, that number stays inside the square root. So on the outside, we have 2 times 2. And on the inside, we have 4 radical 2. Okay? Now on the perfect squares method, you're thinking about a perfect square that fits into 32. Okay, and you're like, wow, we just did 4 and 8, so let's do that. Square root of 4, square root of 8. And the square root of 4 is 2. And we have 2 radical 8. But that doesn't match the other one. That's because we didn't find the biggest perfect square. Okay, there was a bigger perfect square that goes in there. So now this leftover one actually still has another perfect square. We can break this into radical 4, radical 2. And now that radical 4 turns into a 2. And we'll have 4 radical 2. Now what was that other perfect square? That bigger one? 16. If you would have got 16 and 2, you would have been done with one little piece of work. 4 radical 2. So if you're going to do the perfect squares method, super important that you try to get the biggest perfect square first. And I'm going to give you a little strategy to help with that. But first, we're going to need to know a lot of perfect squares. Okay? So the little ones here, you're probably pretty bored with, and you already know them by heart. But we're going to go all the way up to 15 squared. And even then, you might need like 20 squared is 400. You might need that. So I'll stop here once I get to the end, if you don't know these, so you can write them down. But we should definitely be able to go, hopefully most of us can go to 10 squared already, or 11 and 12. And it's not too much of a stretch to push ourselves to 15 squared. And we're going to throw on 20 squared too for 400. Okay? So for most of us, 1 through 10 is pretty good. 11, 121, 12, 144. Okay, 13 squared is where we start to lose it. 13 is kind of a funny number, and it's going to be 169. And for whatever reason, kids always have an easy time remembering 169. Well, the next one is just the reverse. 14 squared is 196. You just flip-flop them. And then 15 squared at that point. Okay, 15 squared is not too much much more to learn. And it's going to be 225. And then 20 squared is going to be 400. Okay? So for these small ones, like 32, I would have started, you're on your list, and okay, 32 is in between 36 and 25. And we're just going to start here and work our way up. Up the list, but down in numbers. So like 32 divided by 25 doesn't fit. 32 divided by 16, bingo. 32 divided by 16 is 2. And I have the ones I should use. Okay? Let's have you try the next 3 there on your own, trying to get the biggest perfect square that fits into each one. Alright, if you need more time, go ahead and push pause and then come back. Otherwise, here it is. Okay, 48 is going to be 16 times 3, and the square root of 16 is 4. 125, that was hopefully an obvious one that we're going to be using 25. 25 times 5 there. And next we have 80, that's going to be 16 and 5. And I was on a 16 kick here, wasn't I? Boom, boom, boom. And guess what? There's like there's at least 2 more 16s coming up. All right, revealing the truth to you. Your calculator, if you type in the square root of a negative 36, tells you it's an error. It doesn't work, it says. Error. Your previous math teachers may have told you that the square root of a negative 36 is not possible. They have lied to you. Your teachers, your calculators, they're lying to you. And I am going to tell you the truth today, that they are possible. You just need to use your imagination. The square root of negative 1 is I. I for imaginary. That's right, the square root of negatives. You can do them, but they're imaginary. The square root of 4 equals 2. So the square root of negative 4 is 2i, or imaginary 2. Okay? Well, let's take this down to here. What do you got for negative 36? The calculator just told us that it's not possible. Error. Well, the square root of 36 is 6, so the square root of negative 36 is 6i. Negative 72. Well, 72 on our perfect squares list, be in here somewhere. 64 is not going to fit into it. 49 doesn't fit into it. 36 does, and we just did that. So here's the trick with splitting these up. Just like I like the perfect squares method, if you like the factor tree method, you're going to have to remember to put an I in there. When I split these up into the perfect square and the other number 2, 36 times 2, we need to put the negative with the perfect square, so we remember to do the square root of the negative. We'll have 6i radical 2. Okay? Think about the square root of negative 24. 24. We're going to go with the negative 4 and 6 for 2i radical 6. Alright, I want you to go ahead and push pause and think about those other ones just down below. And let's see what you can do. Ready, set, go. Alright, check it out. Negative 96, we're going to go with negative 16 and 6, which gives us 4i radical 6. Negative 112 is negative 16 times 7. I told you I was on a little negative 16 kick today here. I don't know what the deal was. And then this was the tough one, negative 432. All right. Lots of opportunities here, lots of different things. that kids have tried. We had a lot of kids trying like 36 and 12. But that leaves you with the 12 that you can break up some more. Okay, so here's the strategy for 432. If you cut that in half, that's 216. So it's like these littler ones, I just go right for that number and then start going underneath of it. But once they get really big, think about it. Once you get really big, what's the smallest number that you can divide something by? 2. Well, you can divide by 1, but that's not going to help you. You can divide it by 2 and have it actually come out to be something else. So if you cut it in half, that gives you your starting point. So 432 divided by 2 is going to be 216. So just inside of there. Does 196 go into 432? 432 divided by 196? No. How about 169? No. 432 divided by 144? Yes. Ta-da! 144 and 3. Okay, and we're going to put the negative on the perfect square. So we'll have 12i radical 3. Okay, adding and subtracting with i's. Okay, so if you have them in parentheses like this with a real number and then an imaginary part, this is called a complex number. Complex because it has both real and imaginary. Okay, when we're adding these, it's going to look scary, but it's actually just combining like terms. So we have 2 plus 7i plus 3 minus 2i. So we're just combining like terms. We have 2 plus 3 for 5, and then you combine the i's. 7i plus a negative 2i, 5i. With a subtraction problem, you got two choices. Okay, you can either do it like visually, alright, because it's kind of small, so it's not too tough to do this visually, and just do like, okay, 5 minus 7 is going to be negative 2. Negative 3 minus 2 is going to be negative 5. Or, you can take that negative sign in there and call it negative 7 minus 2i, and then now you can just go like that. With your 5 and negative 7, and then minus 5i. Okay, so those are your options with that. Math rules. Math rules. Okay, let's talk about some math rules now with our square roots and i's. It's not good math grammar or acceptable math practice, math syntax, whatever you want to say, to have a square root or an I left in the denominator. So here's what we're going to do. Okay, so we have a square root of 3 on the bottom, and we just learned that that's not good math practice. You're going to multiply by that square root of 3 to the top and the bottom. Okay, how come we're going top and bottom? I thought we had to go do the same thing to both sides of the equal sign. Well, there is no equal sign here. And what is the square root of 3 divided by the square root of 3? 1. Anything divided by itself is 1. And when you take 1 times something, it does not change the value of that something. So this is still the same. This is still the same. It's going to look a little bit different, but it's still going to be the same if you type it into the calculator. So now I have a 5 radical 3 on the top. And now you got to tell me, or you got to think about what works best in your brain. When you do a radical 3 times a radical 3, do you go radical 9 in your brain and then take it to a 3? Or do you do radical 3 times radical 3 is regular 3? Okay, either way, you got to think about what works in your brain, what's going to make sense. And now I know you're already looking at that and thinking, Mr. Handke, that has 3 numbers in it, and the other one only had 2. I agree with you. I do. I don't make the rules, though. Okay? Although that looks nicer, this is the simplified answer. Okay? Same deal with i's. Alright? It's not good math rules here, math practice to have an I in the bottom of your answer. So you're going to multiply the top and the bottom by I. All right, we have 5I over 3I times I. That's 3I squared. Uh-oh. We got another piece of knowledge coming at you here. I squared. Well, if you turn back to the front where we first learned about I, it was the square root of -1. What happens if we square both sides? And we get I squared. Square and a square root should cancel out, and we'll get -1. So I squared is -1. So now I have 5I over 3 times -1. That is 5I over -3. Okay, and when you just have like one piece divided by one piece, that negative can go wherever. It does not matter. Well, I wanted it to be in the front. Darn it. -5I over 3. Alright, so you could have 5I over -3, -5I over 3, or negative in the front, 5I over 3. Alright, I didn't know how much time we would have for class, so I have all these problems on here. We had time for about half of these on the back. So let's drop down to the last one. 7 minus radical 6 over radical 2. So we just learned about multiplying top and bottom by radical 2. But there's two things on the top. So we got to do parentheses around those and take this to both of those. So we have 7 radical 2 minus radical 12 now over regular 2. Okay? Radical 12, I could call that radical 4, radical 3. So we would have 7 radical 2 minus 2 radical 3 all over 2. And I can tell your brain's looking at that and you want to cancel that out, but you can't cancel it out in one big group like that. Because in order to cancel out the whole big group, you have to be able to divide both parts by that 2. But, and this goes back a long ways in your fraction knowledge, you can break these apart to 7 radical 2 over 2 minus 2 radical 3 over 2. And then these would cancel out. And now you have 7 radical 2 over 2 minus radical 3. Okay, there it is. You know, I don't know if I would require you to do that on a quiz or a test. If you could reduce both parts by 2, that would definitely need to be reduced on the quiz and test. But if it's only going to be 1, I'm not sure if I'm going to make you split those up yet or not. We will talk about that more when we get to the test review sheet. Okay? All right, thanks for watching, kids. Best of luck, and let me know if you have any questions.